Assalamu alaikum, dear students. Let's start like an email here. Hopefully, this class finds you well and in high spirits because you need that a lot. You will need that, in fact. Today, we are going to discuss chapter 3, periodic properties of element and chemical bond. And you obviously know that we are going to discuss lecture 2 because it is written here. Nothing to predict. Nothing complex over here. What are we going to learn today? We are going to learn about p-block elements. As I have mentioned it earlier in my previous lecture, lecture 1, if you have done it already, you should know that I have given enough trailer about p-block elements. I think once a trailer gets interesting, we feel interested to the movie. So now welcome to the movie and we're going to watch it because it is very important. I think my opinion doesn't matter to you, but these statistics should matter to you because you will appear for the medical admission test and you can see how many times this p-block element occupied or dominated the questionnaire. So let's not waste any more seconds. Let's jump to the question. First question, which of the following is a superoxide? First of all, I would like to mention that one of the most common question that appears in medical admission test from the p-block is the question regarding oxides. You need to learn about the types of oxides and their examples. This is very, very important. I'm writing it down and making it easier for you. Types of oxides and examples. This topic is very, very crucial. If you can memorize all the information that I'm going to provide, then you will be able to answer at least 1 or 2 questions in your upcoming admission test. By admission test, I just don't mean a medical admission test. You will find such question also in varsity admission test as well. So we are going to learn about oxides and their examples at first, and later we will solve this question. Actually, there are no specific statement in the book. There is no specific statement regarding the types of oxide. In our books of different writer, we do not see such a statement that oxides are divided into 4 types, 5 types, 6 types, 7 types. Actually, there is no such thing written there. But from all the book, we can get around 9 types of oxide. 9 types of oxides. So what are those? Let's start with the easier one. As we all know, oxides can be acidic or oxides can be basic. So first, start with the acidic one. Acidic oxides are those which are acidic in nature. I think I don't have to elaborate this way. Rather, I should provide the example. You should know that all the non-metallic oxides are acidic oxides. So I'm writing it down in this way, that all the non-metallic oxides are the acidic one. Next, we are going to learn about basic oxides. Basic oxides. So I think you can easily assume what will be the example of basic oxides. Since non-metals are opposite to metals in property, so we can certainly say that all the metallic oxides are basic oxides. But by this time, some different oxides should pop in your head, that I have heard that aluminum oxide is an amphoteric oxide, but according to your principle, it should be included in the basic oxide. So how can it show acidic nature? Actually, there are some oxides which have both property. They can act as an acidic oxide, they can act as basic oxide. They have dual nature, for which they are named amphoteric oxides. So we do not have to remember each and every examples of the acidic and basic oxides, but we do need to recall at least 5 to 10 amphoteric oxides for the admission test. So now I'm writing the crucial one. So it should be written in red, which is amphoteric oxide. Amphoteric oxides are those who possess dual characteristics, but we need to learn the examples. I will provide a Bangla mnemonic to remember all the examples here. What are the possible examples? If we write zinc oxide, titanium oxide, aluminium oxide, indium oxide, germanium oxide, stannous oxide, PbO2, that is lead suboxide, and also lead oxide. Moreover, beryllium oxide. So we are watching that these are the amphoteric oxide, but how I could recall all these examples? Did I memorize all? No, I just memorized the mnemonic and I regenerated the examples from the mnemonic. What is the mnemonic? Let's see. In Bangla, Johnny, Tumi, Aaj, India, Gele, Shona, Pabe, Bollam. Okay. Actually, I should give an arrow so that you can find the order easier. Johnny, Tumi, Aaj, India, Gele, Shona, Pabe, Bollam. So with this mnemonic, you can easily recall at least how much? 1, 2, 3, 4, 5, 6, 7, 8, 9, at least 9 different amphoteric oxides for the exam. Out of this, all the questions come. So you can be assured that if you learn all this, then it will be enough. Moreover, we have a different type of oxide, which is I'm writing it down here, which is neutral oxide. Neutral oxide. Those do not possess any characteristic, neither acidic nor basic. These are called neutral oxides. Neutral oxides can easily be remembered in this way. Ko no pani nai. You should try to recall the oxides using this mnemonic. Ko no pani nai, which is neutral oxide. So we got 4 types actually, not 5. Let me correct it. 4 types of oxides. Okay, what are the remaining 5? As I've already mentioned, there are 9 types of oxides. I just wrote only 4 types. What are the rest? Let's see. Here, the question asks about superoxide. What is superoxide? A superoxide is such oxide where oxygen is more than it's supposed to be. Suppose potassium has +1 charge, so it should it should be 2 in number to occupy 1 oxygen. So the ideal formula should be K2O. But instead of K2O, instead of more potassium, we are seeing more oxygen. That's why I'm mentioning, or I'm labeling it as superoxide. Superoxides are those where more than enough oxygens are there. I mean, in a compound, the supposed number of oxygen is fixed, but if it gets more than that, then this oxide can be called as superoxide. What will be sodium oxide? This can be called as sodium peroxide, because here the oxidation number of oxygen, if becomes -1, then we can call that oxide as peroxide. Okay, so sodium peroxide. Like sodium peroxide, we can also write hydrogen peroxide, a very common peroxide. So let me use the numbers. This is the 5th type, this is the 6th type. What is that? Looks like it is a mixture of oxide. Exactly. If we react PbO2 and 2 lead oxide, then we will get the lead PbO3, PbO4. So this plumbic oxide can be labeled as mixed oxide. Like this, we can get Fe3O4, Mn2O3. These are the mixed oxides, which is our 7th type. And lastly, in the bottom section, we are seeing manganese oxide. Here, the oxygen is also more than what it is supposed to be, but we know manganese got variable oxidation state. That's why it's possible to hold number of more oxygen. It's not like that of potassium. Potassium got fixed oxidation state. Instead of having fixed oxidation state, it's carrying more than it's supposed to be. But if an element possesses more oxidation state, then it naturally can occupy or hold more oxygen if it wants. In that case, we can't label them as superoxide. We have to name it as polyoxide. Polyoxides can be memorized in the following fashion: polyr. I mean, we have only 2 examples: manganese oxide, lead oxide, which is MnO2, PbO2. So sometimes we can recall it like this: polyr mon pabe. Looks like a name of Bangla cinema, yet it is very effective to recall polyoxides. Polyr mon pabe. Okay, so polyoxides are the 8th type. Now what's left? You got it right. The last one is the suboxide. Suboxides are the quite opposite of superoxide. Suboxides carry less oxygen than it's supposed to be. I mean, if you see carbon, suppose it is the normal version of the oxide of lead will be PbO, lead oxide. Instead of lead oxide, I mean PbO, if we see that 2 lead atom gets attached with single oxygen atom, it can be written as Pb2O. So we can see the number of oxygen is less than it's supposed to be. Here, the number of oxygen is more than it's supposed to be, but here the number of oxygen is less than it's supposed to be. If it is less, then we should call it suboxide. If it is more, then we should call it superoxide. But first, we have to check the element which is holding that oxygen. If it got variable oxidation state, then we should jump into polyoxide. But if it does not have any multiple oxidation state, then we can label it as superoxide. But actually, to make it easier for you, the examples that I have written here is enough for the admission test. You don't have to find out any more polyoxides apart from these 2. Again, you don't have to find out any more suboxide apart from this one. Similarly, no more superoxide will be needed in your exam. If you only can recall this one, it would be enough. So to summarize it, I should say this is a very important slide, and you should note it down in your copy, and you should fix it somewhere at your table so that you can always see and always practice these types of oxides. So what will be the answer for this question? Is it D? No. I have said already the superoxide will be potassium superoxide, which is KO2. Okay, let's move on to the next question. Which of the following oxides will produce the strongest acidic solution? Strongest acidic solution in aqueous medium. So let's practically do that. Carbon monoxide is a neutral oxide, right? Just a few minutes ago, we have studied that it is a neutral oxide. A neutral oxide will not create an acidic solution, so it's out of the option. Silicon dioxide. Silicon dioxide is a semi-metallic oxide, which is a bit acid. Actually, it's supposed to form acidic solution, but though it creates acidic solution, but it is very mild, since it is not actually metal, not actually non-metal. It is metalloid. For this reason, it generates a mildly acidic solution. It will not be the answer. P2O5, on the other hand, which is phosphorus pentoxide, certainly react with water to form H3PO4, or phosphoric acid, which is certainly most acidic among the 4 options. Because for carbon dioxide, it will be carbonic acid, which is a weaker acid, like silicic acid. So B and D is ruled out or excluded. The correct answer will be option C. It will create the strongest acidic solution. Now, which of the hydroxide is acidic? Boron hydroxide or boric hydroxide. Actually, this is boric acid. It does not look like an alkali. It is actually a acid, and it is also known as boric acid. This is nothing. Actually, some students presume that if any compound have hydroxyl in its end, then it will be a base, it will be an alkali, but it does not happen for boric acid. You have to look which type of hydroxide it is. If it is metallic, then it is supposed to be basic. If it is non-metallic or semi-metallic, then it certainly will act like an acid. So the correct answer is A. Rest of the options will generate basic solutions, or these are basic hydroxides. Which one is the principal element of optical fiber? This is a question that appeared from use. We should look for such uses in our book. Actually, it is written in a very short paragraph, written as no more in the last portion of this chapter. If you can recall, you will certainly be able to find that in your book, and you should put a 3-star in that area. I should say the answer is very common. It's known to you. We don't have to explain it more. The answer is silicon dioxide. Moreover, I should add that this calcium, magnesium oxide, these are found in soil. And also I should say that this magnesium is used in photographic flash bulb to make it brighter. Which one is the amphoteric oxide? We have already studied that. First one, carbon dioxide. This one is an acidic oxide. Next, aluminum oxide. This one is amphoteric. Amphoteric. Magnesium oxide. This one is basic oxide because this is a metallic oxide. And lastly, sodium suboxide, right? No, it is not sodium suboxide. It is sodium oxide, and it is certainly basic in nature. So the correct answer will be B. What is the most inert element after inert gas? This is also a very classical question that we all should know. If you look at the periodic properties, you will find a certain property named electron affinity, and you will find that all of the values, all of the element, almost all of the elements show negative electron affinity. But for inert gas, you will find that inert gas will show positive electron affinity. That means it does not require any electron, nor it wants to donate an electron. On the other hand, apart from inert gas, there is only one element that shows positive electron affinity, which resembles or represents its inertness, which is nitrogen. Nitrogen is so inert that it requires 3000 degrees Celsius temperature and thermal lighting to get broken, or to be broken enough so that the atoms can split and participate in the nitrogen cycle. So this is a very high bondage relationship. Next question, we see that which oxide is acidic in nature? Acidic nature should be non-metallic oxide. So this one will not be answered. This one is also not correct. Final option is the correct one, which is carbon dioxide, as it is a non-metallic oxide. Okay, as this is a non-metallic oxide, this one will be acidic in nature. The p block elements of the periodic table are called p block element. How many elements are there in p block? There are around 36 elements, right? And now what they can be called? Basically, p block elements are p block elements always follow the rules that are imposed upon them. I mean, Aufbau rule, Pauli's exclusion principle, Ohm's rule. All these are applicable for p block elements. Since they all follow the Aufbau rule, they can be termed as or labeled as ideal elements. As we have discussed that in the earlier chapter, we have mentioned that S block and p block elements are ideal or representative elements. Those who are ideal can be used as representative. As they're ideal, we want to represent them. That's why we can call them representative element. Actually, this is a kind of wrong translation. It should be written as representative element, not replica. So I'm writing the correct one. You should note that down as well. Representative, and also known as ideal elements. Okay. Alkaline earth metal, this is group 2. Heavy metal, D block and F block. Transition element, this is within the D block. Okay. Next slide. In this question, we can see that which one is liquid at normal condition. As we all know, the only liquid non-metal is bromine. So the correct answer will be bromine. Okay. Now you might also wonder what are the liquid nonmetals. Liquid nonmetals can be recalled or memorized in this way: France, Gie, Haji, size. But I always try to put emphasis on mercury because mercury is the most known liquid metal to us. That's why if you even get all these four options, you should mark mercury. Mercury is the one. Okay, liquid metals, we should actually not liquid non-metal, it should be liquid metal. Okay, it is liquid metals. Liquid metals are francium, gallium, mercury, cesium, but among all these four, mercury is the most correct one. Okay, which is used in the treatment of cancer. We know cancer requires chemotherapy, radiotherapy, so something radioactive might help in cancer. Helium, neon, argon, these are not radioactive. Which one is radioactive? Certainly radon. Then what is the purpose of all this? We should also, I'm writing it down here, please read all the uses of inert gas. This is very, very crucial for your upcoming exam. Suppose helium, you need to know that it is used in a cylinder, in cylinders for diver. What will be the percentage of helium? 80% helium and only 20% oxygen. Why? Because actually we don't require more oxygen than that. We require 20% oxygen, and rest of the portion of the cylinder should be filled with a lighter gas so that diving and ascending does not get heavier. Next, we should write that neon is used for aeroplane light. And also we should mention that argon is used in electric bulb to create a neutral environment. But if you ask about tube light, which inert gas is used in tube light, then the answer will be krypton. Okay, these are some information that you can learn from that, which you will be able to find in book as well as Meditrix. Okay, let's move on to the next question. Which one is not a metaphoric form of arsenic? Metaphoric, not metaphoric, actually metamorphic form of arsenic. Okay, in case of arsenic, we find gray, black, and yellow. These are the three types of metamorphism that they show. But we do not find any white kind of metamorphism, or we do not find any white arsenic. So this will not be the answer. It appeared in the medical admission test 13, 14 session. So very crucial. Which one is not a mineral source of fluorine? Sylvine, carnallite, kyanite. These are found in the stones, in the soil. That's why they are mineral source. But as you can see, brine is the saturated solution of sodium chloride. It is a solution. It will not be the mineral source. Okay, the mineral source means it will be found in the ore. So the answer will be here. B will not be found in the ores. Sulfur cannot bind with metals directly other than. It appeared in my admission test, but such informations are not available right now in the books. Current books do not have such information, but you should know that actually sulfur is very reactive. It can bind with any metals if they want, like zinc, iron, silver. These are reactive metals, and sulfur can easily get bound with them. But with inert metals or not reactive metals, I mean which metals? Those metals actually which are placed at the bottom of the reactivity series are the least reactive one, and they do not usually react with anyone, let alone sulfur. So we have one element from that group, which is platinum. So it will not react with sulfur. Sulfur cannot bind with metals directly other than platinum. Okay, next question. What is not the characteristic of nitrogen? Actually, it is called nitrous oxide, which is also known as laughing gas. Laughing gas, this is actually colorless. This is soluble in alcohol. This is soluble in cold water. But unfortunately or fortunately, it doesn't have any bad odor. I mean, who loves a bad odor? Something should be nice to smell to make you laugh, right? Which one is the correct? You should also know that nitrous oxide. This nitrous oxide, first of all, this is a neutral oxide. Neutral oxide. Next, you should know that it can be used as anesthetic. It can be used as laughing gas. Not even that. Those who are a fan of racing games, you will find N2O as propellant, which ignites in the back and gives a thrust that pushes or accelerates the car or vehicle, which is also known as NOS. Okay, which one is the correct order of activity of halogens in upward sequence? In case of halogen, we know that fluorine, bromine, iodine, this is the order, and from top to bottom, their electronegativity gets decreased. So here, if we can see that fluorine will be the most reactive or highest reactive. So in this way, we can easily state that fluorine will be more reactive than fluorine, fluorine will be more reactive than bromine, and bromine will be more reactive than iodine. But I should also provide you an interesting fact that electron affinity of fluorine is certainly less than fluorine. You already know that. Since fluorine is of smaller size, fluorine is a bit larger, so fluorine can easily accommodate one more electron, but fluorine can't. That's why fluorine should be a less reactive than fluorine. But in our book, the answer provided is this. And also, if we look at all other options, we do not see such an order where fluorine is placed before fluorine and the rest of the order is correct. So we don't have any other option but to answer this option C. Okay. At which temperature helium turns into superfluid? This is also information that appeared in my admission test, and it made my mind blew away right that moment because I didn't know that. And I think you also don't know about that answer because you don't see such information in your book. Whatever, you just learn it and engulf it or vomit it, whatever you do, just learn that helium turns into superfluid at 2.17 Kelvin. No other temperature is necessary to learn because it appeared in the exam. We are just learning it because if it gets repeated in the question, so that we can answer. Liquid nitrogen can create temperature. This question does not have any answer. Why? Because liquid nitrogen can create minus 196 degrees Celsius. So the answer will be blank here. What is used in energy saving bulb? As I have said already, in electric bulb or energy saving bulb, we use argon. Okay, which inert gas has the vaporization heat of 1.7 kilojoule per mole? This answer is also just for learning the previous or solving the previous admission test question. For the purpose of solving the previous admission test question, we kept it, but it does not belong to current preparation. Okay, don't bother about such information. But if possible, remember just this information. Which one is right? Silicates are high molecular weight polymers. Certainly, silicon dioxide or silicates form giant polymer. They form giant polymer, and it shows high melting point and boiling point as well. Carbon tetrachloride is not a coordinate compound, it's a covalent compound. So it will not be correct. It is covalent compound. Silicon is found in granular form. Silicon is agranular. So there should be an A for that. Graphite is semiconductor. No, graphite is only non-metal, which is very effective in conducting electricity. And graphite is mostly used in the electrolytic cell. Electrolytic cell, not electrochemical cell. In electrolytic cell, graphites are used as electrode. Okay, which compound is volatile? What is volatile? Volatile means something that is in liquid form, but it does not require any heat to get evaporated. It evaporates by itself at room temperature. Now, which one is volatile? Stannous chloride, sodium hydroxide, lead chloride? No, the answer is silicon tetrachloride. Okay, we should already remember this. Silicon tetrachloride. We know that silicon tetrachloride from a question that usually appears in our HSC examination. Like carbon tetrachloride cannot be hydrolyzed, but silicon tetrachloride can be. Why? Because silicon possesses a d block, a d orbital that is vacant to accept the electrons from the ligand to get hydrolyzed. Moreover, we should also know that silicon tetrachloride is a volatile compound, which is not correct. Silicon is used to make computer chip. This is correct. Methane gas is needed to produce pure silicon. This is also a bit correct. Silicon is used to make metal alloy. No, silicon is used to make semiconductors, not alloy. Semiconductor means cheap transistor. Silicon itself is a semiconductor. Quartz in soil is present as silica, and that's also correct. What is the number of p block element? I have already mentioned that. 14 is the number of S block element, 36 is the number of P block element, 41 is the number of D block element, and 27 is the number of F block element. If such question appears in your admission test, and if you mistakenly mark the wrong one, then you will dig. You'll think that you have dug your own grave. Okay, you can't mistake this question. I mean, this is the easiest one, and if in our admission test, a harsh reality is that very few questions will be difficult one. Most of the questions will be easy, but the twist is if you fail to answer the easier one, then you will leap behind. You will go you will go beyond many people. So that you will not be able to find your seat in your desired medical college. I will try to give you my example. I got 74.25 and secured a place in Sarsfield Medical College, but 74.5, securing 74.5, someone could get Dhaka Medical College. So I assumed, or I presume that 0.25 will not make any difference. I will be able to migrate myself to Dhaka Medical College. But when I get to admit myself, then I found that with the 74.25, we are, 35 students that were there who got the same number as me, and we all took our classes together, and we could not. No, none of us could migrate because very competitive. There were three. I should say that there are three classmates of mine who got 74.5, still could not migrate to DFC. So I am just trying to put emphasis on the narrow margin that you are going to face in the admission test. You have to fight for each and every number. If we did not mark any mistakenly marked question, which cost us around 1.25 mark, then we could have got the desired number and secured our place in our dream. Right? All of us dream about Dhaka Medical College, but still, every medical college is good if you are good, and if you are bad, then no medical college would be suffice to provide you that knowledge or impart you that knowledge that you seek. Okay, which is the first P block element? The first P block element is boron. This is a very easy question. Which compound is hydrolyzed? The compound which gets hydrolyzed is silicon tetrachloride. Why? Because it got vacant d orbital. Vacant d orbital in the central atom is the precondition of getting hydrolyzed. Which one forms tan molecule? This is also discussed earlier. Silicon dioxide. Which compound is impossible? Nitrogen trichloride is possible, but nitrogen pentachloride is not possible because nitrogen do not have the d orbital to expand their octet. Okay. Which inert gas is not a p-block element? Helium is an s-block element. This is not a p-block element. You should remember that. Though it is placed in the group 18, but it belongs to s-block due to its electronic configuration. Which element forms acidic oxide and acidic hydroxide? Certainly a non-metallic one. So sodium, magnesium, sulfur, fluorine. Which would be the answer? Fluorine does not have any oxide. You might wonder that why not fluorine? Fluorine doesn't have any oxide. So fluorine is excluded from the option. The answer will be D. You should know that fluorine does not have any oxides. Which oxide is acidic? Silicon dioxide is acidic. Silicon dioxide is a metalloid oxide. It is not basic. It is acidic. Aluminum oxide is amphoteric. Water is a neutral oxide, and sodium oxide is a basic oxide. Which oxide will be most acidic? Here, if you can see, as I have already mentioned, that silicon dioxide will generate mildly acidic solution, or it is a mildly acidic oxide. P2O5 will generate phosphoric acid. Sulfur trioxide will generate sulfuric acid, but fluorine oxide will generate perchloric acid, which is the strongest among all these four. So the correct answer will be B. Which one is amphoteric oxide? Beryllium oxide. We have already learned that mnemonic. Johnny, tumi aaj India gele, shona pabi pabe bollam. That bollam represents beryllium oxide. What is the form of aluminum chloride? Actually, aluminum chloride stays in dimer. One aluminum chloride binds with another to form the dimer. We will discuss the structure in a upcoming question. Which is the number of metalloid? I have already discussed that in the previous lecture. The number of metalloid is 6. And what are those? We can easily remember with this mnemonic. Boro chele jeno aaj shob theke matal. First of all, boro means boron. Chele means silicon. Jano means germanium. Aaj arsenic. Shob antimony. Theke tellurium. And with this matal, we should know that this is metalloid. Okay. Next question. In which compound the oxidation number of oxygen is -half? Oxidation number of oxygen becomes -half for superoxide. Superoxide. Okay. These two are peroxide because here the oxidation number will be -1. Which type of oxide is silicon dioxide? Already answered that 3 times. So the answer will be acidic. Which of the following oxides act as desiccate? Actually, I should write down as drying agent. Drying agent. Many of you are confused about drying agent and dehydrating agent. What is drying agent and what is dehydrating agent? Let me make it very clear to you. Drying agent does not participate in reaction. It is not a reactant. It just stays within the system to absorb any water from the surroundings to keep the reaction impurity free, okay? So that it does not manipulate the process of the reaction. So it stays within the environment and it dries out the environment. It absorbs water from the environment. On the other hand, the dehydrating agent, it acts as a reactant and it participates in the reaction and removes the water, any water that is generated in the reaction. So one takes away the water or water vapor from the environment, and other one takes away the water or water vapor from the reaction. And now we have to remember the examples. In our book, there are plenty of examples about dehydrating agents, but there are few examples on dehydrating agent. I mean, drying agent, there are lots of examples, but there are few examples in dehydrating section. So we should opt for the smaller one. First of all, I would like to mention 2 examples, P2O5 and sulfuric acid. These two can act as both drying agent and dehydrating agent. So if we get these two in option, then we don't have anything else to do. Whatever may be the question, if it is a desiccating agent or drying agent or dehydrating agent, we can easily mark if any of these two are available. So what are the rest that we need to remember about dehydrating agent? As I have said already, if you fail to learn only 3 examples from this section, it will certainly be a sin. In Bangla, it will be a pap. I'm just writing this Bangla in English version. Pap. Okay. Now find out what does it mean. With P, I meant phosphoric acid. With A, I meant aluminium oxide. And last, potassium hydrogen sulfate. These 3 compounds act as dehydrating agent along with these 2. Rest of the examples which are not known to you, you will mark as drying agent. I think it got simpler, and now we will answer this question. Which one will act as drying agent? As we can see, we have got the option that we asked for, phosphorus pentoxide. It is easier. Even if the question becomes which one is a drying agent or dehydrating agent, the answer will be same. Okay, atomic number of an element is 35. Atomic number is 35. In which block is the element located? Okay, as you know, we just have to compare it with the nearest inert gas. You know that helium, neon, argon, then comes krypton, which got the atomic number 36. Okay, so 35 will be immediately placed just an immediate before the krypton. So the group will be 17, and we all know the 17th group belongs to p block. Okay, we can determine the group. We can determine the period as well with this. How? Krypton is 36. Krypton is 36. So here there will be 35, which is also known to as fluorine. It is bromine. Now the group is 17. What will be the period? First, second, third, fourth. So the period will be fourth. Along with determining the block, we can easily determine the group and period with this formula. Just you get the atomic number, compare it with the nearest inert gas, which is the rare gas. You should also know that all the inert gas can also be termed as noble gas, can also be termed as rare gas, can also be termed as bridging elements, but by no means they can be termed as ideal gas. By no means. There is no such thing called ideal gas. These are the 4 titles There may be more titles, but we should know all these four for the admission test. So the answer will be argon. Okay, what is the acidity of aluminum oxide? How will we determine the acidity? Actually, to determine the acidity, we need to react. We need to react that oxide with what? Acids. If we react them, aluminum oxide with hydrochloric acid, then we will find that it will generate AlCl3 in dimer version. So it will be like Al2Cl6, and along with that, it will generate water, and it will require at least 6 hydrochloric acid. So aluminum oxide can neutralize 6 mole of hydrochloric acid or 6 moles of monoprotic acid. So certainly its acidity will be 6. But on the other hand, this is the way to determine the acidity. How we will determine the acidity? Since aluminum oxide is an amphoteric oxide, we can also determine its basicity. How? To determine its basicity, we need to react aluminum oxide with a monohydroxylic base, which can be sodium hydroxide. As we know, the following reaction will generate sodium aluminate along with water. As we can see, aluminum hydroxide will certainly react with 2 sodium hydroxide to generate such compound. In this case, the answer 2 actually represents the basicity. So with this question, I have also already provided the way to determine acidity and basicity of different compound. The 41st question says that how many lone pair electrons are there in the dimer of aluminum chloride? Okay, now let's draw the formula. Suppose this one is aluminium, this one is also an aluminium, and aluminium is receiving the free electrons or lone pair electrons from the chlorines, aluminium chloride. Similarly, aluminium chloride. Okay, actually it will not be an arrow, it will look like this way. Okay, now which will be the coordinate bond? If we look at this, then you will find that this chlorine molecule, this chlorine atom will provide aluminium the lone pair electron. Again, this chlorine molecule, chlorine atom will provide the aluminium of this molecule the lone pair electron. We can write down in this way. Okay, so how many lone pair electrons are there in the dimer of aluminum chloride? Now let's find that out. In this chlorine, there will be, since one of the atom is participating in bond, one of the electron is participating in the bond, rest there will be 3 lone pair. Here we can also see 2 lone pair. Here we can also see 2 lone pair. Here we can see certainly 3 lone pair electron. So let's count it. We get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we got the answer in the option. So the correct answer will be 16. In this way, aluminum creates a dimer, and there are 16 pairs of electron or lone pair electron within this dimer. What is the basicity of sulfur dioxide? How we determine basicity? We just react with sodium hydroxide. So what will be the scenario here? We will get sodium sulfate plus water. To make sodium sulfate, we need at least 2 sodium. So the correct answer will be A. This is the ideal approach to determine acidity or basicity. Someone might teach you like this: number of metal into their charge. It will eventually pop out the result of their acidity. But in that way, there are some exceptions where you will not be able to find the correct answer. So you should follow the ideal approach, or you should try to follow the ideal approach when in doubt. What are the number of covalent and coordinate bonds in the aluminum chloride molecule respectively? This is also a question that can be answered from that figure. Should we draw that down again? Okay, no problem. I'm drawing it again. This is aluminium. This is aluminium. Now, here is a chlorine. 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 Now, first the covalent bonds. Covalent bonds. Now the coordinated bonds. Okay. Now the question is the number of covalent and coordinate bond. So we can see the coordinate bond is only 2 in number. Rest of the options do not have any 2. So we don't even have to calculate the covalent bonds. We can easily say that the option A is correct. Which one is a noble gas? Easy question, that is xenon. Which block do the chalcogens belong to? Chalcogens are group 16 elements. Group 16. Actually, not the whole group 16. The first 4 members of the group 16 are named as chalcogens since they are found, or their compounds are found in ores. Which block does chlorine belong to? Very easy question. Chlorine belongs to 17th group, which is group of halogen, and it lies within the p block. Which 2 groups of periodic table are called pnictogen and chalcogen? Pnicto in Bangla, it starts with P. Ponero starts with P, so you can easily relate that. Pnictogens are the group of apneutic gases. Actually, it heads by the gas, the group 15 heads by the gas nitrogen, which creates some breathing difficulty or responsible for some breathing difficulty. But rest of the members are not responsible for breathing difficulty. Yet the whole group is named as pnictogen. It's like a terrorist. One person in the family become terrorist, but the whole family gets a label as terrorist family, right? Whatever, the answer is group 15 and group 16. So the correct answer will be C. Which is an interhalogen compound? Interhalogen means the compound is within the halogen. So it is easier to recognize that option. Chlorine and chlorine is there, so it is interhalogen compound. Which of the following is not a semiconductor? Semiconductor, as we have said, that metalloids can be semiconductor. So gallium arsenide, silicon, germanium, all these can be a semiconductor. But argentum, I mean silver, no way. Silver is the highest, silver is a metal that shows highest electrical conductivity. So no way it will become a semiconductor. Which of the following acts as both an oxidizing and a reducing agent? Which acts both as oxidant and reductant? We can easily recall or remember with this formula. O সাথী ফিরবে না না হাই. These examples are both oxidant and reductant. Both oxidant and reductant. So as we can see, nitrous acid, actually with this NO2, we can also write HNO2. What is the principle of being oxidant and reductant both? Actually, when the central atom of a compound shows the highest oxidation state, then it cannot be oxidized any further. So it can be reduced. And those who can be reduced act as an oxidant. So I can say in short, central atom showing highest oxidation number, then the compound is an oxidant. Lowest oxidation number, then the compound is reductant. So what happens in between? If an oxidation state of which is in the middle in between highest and lowest oxidation state, then it will certainly act both as oxidant and reductant at times. The next question is, which of the following can be used to dissolve lead oxide? Actually, lead oxide can react with hydrochloric acid, can react with sulfuric acid, can even react with nitric acid. But what will be the resultant compound after the reaction? Here, it will generate lead chloride, which is not soluble in water. Here, it will generate lead sulfate, which is also not soluble in water. Lead nitrate is soluble in water. That's why we can say that lead oxide can be dissolved by nitric acid. Diamond and graphites are the polymorphs. Actually, we can also say them as allotropes. Actually, this polymorph is not the perfect English of this. It is also known as allotropes. Diamond and graphites are allotropes of carbon, which statement is not true in their case. Both are composed of carbon, it is true. Diamond and graphite are sp3 and sp2 hybridized. This is also true. Both have the same heat of combustion. No. This option is incorrect. Heat of combustion for graphite is more than heat of combustion of diamond. Both have different electrical conductivity, certainly. Diamond doesn't show any electrical conductivity, while graphite is a very suitable conductor. Which is metalloid? Metalloids can be remembered with the following mnemonic. Boro chele jano সব থেকে মাতাল. With the boro chele jano with jano, we remember germanium. Which of the following oxides is acidic? I think you can be able to answer this question. Acidic means non-metallic. So which one is non-metallic? Lithium oxide, magnesium oxide, sodium oxide? No. Fluorine oxide. Though fluorine does not generate oxide naturally, but I think actually fluorine doesn't show any variable oxidation state. This is the answer actually I was trying to teach. You should know that fluorine does not show variable oxidation state. That's why we will not get multiple types of oxides for fluorine. This is the only type of oxide you can get. Okay, what is the majority of p-block element? Majority of p-block elements are non-metal. We know in p-block 36 elements are there. So what will be the number of metal, non-metal, and metalloids? We already know p-block contains 6 metalloids. We know that our whole periodic table contains 18 non-metals. Out of 118 elements, there are 18 non-metals. And you should know that only 2 non-metals are placed in S block, which are hydrogen and helium. So if we remove those two, we certainly get 16 non-metals which are placed within the p block. So 16 non-metal, 6 metalloid. How much will be the sum? It will be 22. And if you add up 14 with 22, then you will get the sum 36. Okay, so you have got the answer. Highest will be non-metal, which is 16 in number. Metal will be 14 in number, and non-metal, or I mean semi-metal or metalloid, will be 6. Is there any magnetic substance? No. Which is the formula for peroxide ion? The peroxide ion formula would look like this. Aqueous solution. Why it would look like this? Because the oxidation state of single oxygen atom will be -1. Aqueous solution of which oxide has pH value greater than 7? Greater than 7 means it is acidic, alkaline in nature. So which one is basic or alkaline in nature? Will it be boron oxide? Will it be beryllium oxide? This is the question. Boron is semi-metal, so it will generate acidic. Similarly, phosphorus oxide, it will generate acidic oxide. It will be acidic. This will be also acidic. So the last option left will be beryllium oxide, which is a metal. But this beryllium is a very stable metal, so that's why its compound looks like more covalent. It does not. Their compounds do not behave like ionic compounds. Which of the following forms acidic aqueous solution? Acidic aqueous solution will be generated by carbon dioxide. Which compound has an incomplete octet? Which one does not follow octet rule? You should know that the group 13 elements usually do not complete octet. Normally, they form compounds where they are electrodeficient. They lack electron. That's how they generate electrophiles. So actually, this question is asking which one is electrophile, and we can see that this boron trifluoride is certainly the compound where all the octet of boron is not complete. So the answer will be B. And in such question, we'll try to answer from the group 13 elements. Which of the following elements of second period has the highest acidity of oxide? Highest acidity will be at the rightmost section of the period. So will it be beryllium, boron, nitrogen, or fluorine? The answer will be fluorine. The atomic numbers of A and B are 16 and 17. Okay, 16 and 17 respectively. What is the nature and energy of their oxides in aqueous solution? Certainly these are nonmetals. Nonmetals will generate acidic oxide, and the more electronegative, the more will be the acidity. So in this case, we can say that option A will be less acidic than option B. Here 17 is chlorine and 16 is what? Immediate before chlorine there is sulfur, right? So sulfur oxide, dioxide, and chlorine oxide. Which one is more acidic? Certainly chlorine oxide will be more acidic. Which of the following is a peroxide compound? Peroxide compound, we have already solved that. What are the rest of the options? This one is superoxide. This one is acidic oxide. this one will be polyoxide. Okay. Which groups of periodic table contain both metals and non-metal? This is a tricky question. Group 1 carries both metal and non-metal, but group 2 does not carry both metal and non-metal. Group 3 does not carry. Do they carry? Actually, group 3 does not carry both metals and non-metals, but group 13 carries. Group 13 can also be written as 3A. So this one is correct. 4A is also correct. So option A will not be the answer. Again, since it has 2A, B is also excluded. I think all these are located within the P block. So certainly they got both metals and non-metals, and certainly the answer will be C. Now, if I ask you, which group of P block does not carry any metal, then what will be the answer? Actually, there are two groups in P block which do not carry any metals. These are group 17 and group 18. Actually, group 16 also, no, there are metals in the bottom section. Okay. Which of the following pairs show a diagonal relationship? You can easily recall the diagonal relationship with the easy mnemonic lemur biral বা লিমা বেরিয়ে এলো বাসায়, লিমা বেরিয়ে এলো বাসায়, লিমা বেরিয়ে এলো বাসায়, which is lithium to magnesium. These, I mean, diagonally placed elements show similarity in their properties. That's what we mean by diagonal relationship. Now we need to find out the proper pair for this question. Lithium beryllium will not be a perfect pair. It would be beryllium and aluminium. Magnesium aluminum will not be a perfect pair. Instead, lithium magnesium or beryllium aluminum can be a good pair. Beryllium silicon is not a pair. Boron silicon is a pair. So correct answer will be D. In acidic solution, nitrite ion oxidizes the iodide ion and converts it to iodine. What happens when nitrite ion gets reduced? If it gets reduced, it becomes nitric oxide, because the negativity becomes positive, the charge gets neutral, so oxidation state is getting higher, which certainly compelling the nitrogen to get reduced. In the next question, which of the following is not acidic oxide? All the options over here we should analyze using the only concept that we know, which is acidic oxides are non-metallic oxides and basic oxides are metallic oxides. So we can see that nitrogen dioxide is an acidic one, sulfur dioxide is an acidic one, phosphorus oxide is an acidic one. The only option which is left is potassium oxide. This is not an acidic oxide. Which class of ion has atoms of +3 oxidation number? If we go for this, we can easily calculate the oxidation state of fluorine using this one. Oxygen will show -2 oxidation state, and together it will be -1. So we can easily say that it will be 4 - 1, and the answer will be +3. So our correct answer will be A. We can easily determine rest of the oxidation state as well, but we don't have to. But I think this way will guide you how to determine that, if in case if you forget or get puzzled. Which element is commercially produced by burning seaweed? By burning seaweed, we get iodine. Iodine-rich salt, very important for better thyroid function. Which of the following is Lewis acid? Lewis acid, actually the Lewis concept tells us that which provides lone pair of electron, then they are those which provides lone pair electron are base, and which accepts lone pair of electron, these are called acids. So now we need to look for compounds that will be seeking that lone pair of electron. I mean, those who will act as electrophile. I can simplify this in this way, that Lewis acid accepts electron, accepts lone pair electron, so it is certainly an electrophile. On the other hand, Lewis base is a nucleophile. So what will be the answer? Yeah, where octet is incomplete, it will act as an electrophile. The group 13 element, I mean group 13 compounds. Aluminum chloride will be the answer. Which of the following is not oxidant? It is also a question that came in my admission test. Carbon monoxide is not an oxidant. It's a neutral one. Why would it be? It is rather a reducing agent. Carbon monoxide is a reducing agent, not an oxidizing agent. Which one is called aqua fortis or strong water? Aqua fortis is nitric oxide. I mean nitric acid. Nitric acid. On the other hand, aqua regia. Aqua regia is a mixture where nitric acid and hydrochloric acid are present in 1:3 ratio. The electronic configuration of halogen element will be NS2np5, because when we the valence shell of the halogen contains 7 electrons. Which group of element can produce neutral oxide? Certainly carbon. Neutral oxides, let's recall kono, pani, nai, right? That was the approach. Carbon is within the group 14, nitrogen is within the group 15, and hydrogen is within the group 1. Now we need to look for the proper option. 2 and 13 is not included here. The correct answer, we have already found that, which is C. What is the oxidation number of fluorine in perchloric acid? Very simple. +1 plus x plus 4 into -2 for the oxygen equal to 0. So it will certainly be 8 - 1, which is +7. So the correct answer will be B. In which of the following molecule the central atom does not follow the octet rule? So what will be the answer? We should search any group 13 elements if there are any. But we can see that there are no group 13 elements, so it is a bit difficult right now. But don't worry, you should know that carbon tetrachloride, here carbon got its all valency occupied. Carbon have 4 bonds. Carbon can maximum have 4 bonds to complete the octet. So here octet is complete. In case of water, hydrogen requires only 1 electron and oxygen requires 2 electrons, which is shared from the hydrogen. So here octet is complete. Nitrogen trifluoride, here nitrogen carries the lone pair electron, and rest of the 3 bound electron, 3 pairs of electron are obtained for sharing in covalent bonds. So total number of electron in the valence shell is 8 for nitrogen as well. Lastly stays xenon. Xenon actually contains 8 electrons in its outermost shell. Moreover, it participates in creating covalent bond with fluorine. So if I can demonstrate this way, xenon is bound with 2 fluorine. So this is xenon's electron and this is fluorine's electron, which is also now xenon's electron. Together with that, xenon got 6 electron as lone pair electron. So total number of electron will be 10 for xenon, which is not complying with the octet rule. Here octet expansion occurred. So the answer will be B. It does not follow octet rule, means either octet is incomplete or octet is expanded. Here we can see the octet expansion. Now what is the nature of the aqueous solution of sodium carbonate? We can see that sodium carbonate Sodium carbonate is a salt that was generated from sodium hydroxide and carbonic acid. Now you should ask yourself which one is stronger. In terms of basicity, stronger. Sodium hydroxide is a very strong base, but in terms of acidity, it is not such strong acid like sodium hydroxide. It is rather a weak acid. Since it is a weaker one, the domination will be from sodium hydroxide's end. In that case, we can say that the solution will be alkaline in nature. Since the characteristics of the base predominates, the solution will be alkaline. Which inert gas element has maximum ionization potential? Maximum ionization potential, it will be helium. Why? Because we know that the ionization potential increases in a period, right? From left to right, it gets increased, and the rightmost element will be helium. So the correct answer will be helium, and it does not get ionized easily. That's why it has a higher ionization potential. What are the ore forming elements? These are called chalcogens. Okay, what are the coinage elements? Let me remind you once again: copper, silver, gold. Copper, silver, gold, which are group 12. No, group 11. Group 11 elements are the coinage metals. Noble metals, is there any noble metals? No. Noble elements are there, noble gases are there, noble metals are not there. But you can mention noble metals. I mean, silver, gold, platinum. These are can be termed as noble metals since they're really expensive and they're used in different ornaments as well as luxury goods, right? Chlorine has higher electron affinity than fluorine. Which is the reason behind this? Because the second layer is larger, and that's why it got lesser electron density, right? So the correct answer should be the size. Size of fluorine is very small. That's why it repels electron. That's why electron affinity gets reduced. Electron affinity of fluorine is less than chlorine, which is -333, and -348 is the electron affinity of fluorine. Which of the following atomic numbered element belongs to p block? Group 3. Which atomic number 3 will be in group 2? I mean in S block. 11, the sodium, which is placed in group 1, and it is also included in S block. 33 is certainly a p block element, which is arsenic, I guess. 43 is B block. Okay, so the correct answer will be C. Ore forming elements are chalcogens, which are included in option B. How many valence electrons are there in arsenic? Arsenic in which group? Group 15, the nitrogens. Nodite pani ashe, shokale, bikale, majrate. This is the Bangla mnemonic that I'm talking about to remember all the nitrogens. Group 15, what will be the valence shell electronic configuration for group 15? It will be NS2, NP3, 2 and 3, 5 plus 10 will be equal to 15. So how many valence electrons are there in arsenic? It will be 2 plus 3, which is 5. Nonmetals are placed in which block of the periodic table? Certainly P block. And also 2 nonmetals are placed in S block, which are hydrogen and helium. Which is an example of octet expansion? Certainly phosphorus pentachloride. Phosphorus trichloride is normal, but phosphorus pentachloride certainly expands their octet. What is the bond order of nitric oxide molecule? Actually, this is a question that is not included in many of the reference books that you read in HSC. But Guha sir and Lincoln sir find this topic interesting, and somehow it used to appear in the admission test, but never in medical admission test. Such questions usually appear in the engineering admission test and Dhaka University admission test. But if you want to learn a bit more on this bond order, I think it would go in vain. You should not waste any such time for learning this type of question. Rather, you should focus on such topics which are more prone to admission test, which are more important for admission test. Anyways, nitric oxide molecule shows the bond order of 2.5. The calculation is a bit difficult one, but I think you should not opt for that. You just remember that nitric oxide shows 2.5 bond order. What is the shape of sulfur chloride molecule? As you can see, sulfur chloride, we need to determine the hybridization. Though it will be taught in the following lectures, I mean, where we will be discussing hybridization, it will be discussed again, but I can do for an example. Sulfur has 6 electrons in its valence shell, and chlorine is a monovalent atom, so there will be 2, as it is no cation, no anion. What I'm writing is half into V plus M minus C plus A. This formula determines the number of hybrid orbital. V stands for the number of valence electron. M represents the number of monovalent atoms. Here monovalent atoms are chlorine, which is 2, and valence electron is 6, and the C and A stands for cation and anion respectively. But we do not mention the charge along with symbol. We just write down the numerical digit only. Here the value will be 4, and 4 stands for sp3, right? If it is sp3, then what will be the shape? You might say if it is sp3, the shape should be tetrahedral, but no such shape is here. Then what will be the answer? Listen very carefully. This sulfur chloride, here we know that sulfur got 6 electrons in its valence shell. Since it got almost 2 electrons in its 2 lone pair electrons in its valence shell, that's why this lone pair will repel each other, and the structure gets deformed from the usual tetrahedral one. It becomes V shape, like water molecule. Okay. Remember, if there is only one lone pair electron, it would be like ammonia, which is pyramidal shape. If there was no such lone pair electron, it would be like tetrahedron. But since there are 2 lone pair electrons, that's why it gets V shape, and such deformation of the shape or change in shape occurs due to the valence shell electron pair repulsion theory. Which of the following base is the strongest? The strongest base will be ammonia, since it got higher Kb value. We know that the bases which shows higher dissociation of constant, higher degree of dissociation, or the dissociation constant value, they are more basic in nature. In this case, ammonia is the correct answer. We will learn about it in our organic chemistry. We know that the amines, the basicity of amine declines in the following way. What is that? This is the basicity of amine. Though among all these options, ammonia is the strongest one, but you should know that second degree amine are stronger than first degree amine, are stronger than tertiary amine, and tertiary amine is even stronger than ammonia. But ammonia shows stronger basicity or basic nature than the aromatic one, which is aniline. Okay, ammonia is stronger than aniline. Okay, which of the following compound is acidic? The first lesson that we have learned today in our first slide was metallic oxides are basic and non-metallic oxides are acidic. So we need to determine which one is non-metallic. Now it's very challenging. All of them are metallic. Then how can we determine a correct answer? Here you should know that when the charge gets higher, then the covalent nature gets higher due to polarization, and in that way they generate in aqueous solution, they generate more acids. I mean, look at the solution. The number of charge is +2, so it will generate almost 2 moles of hydrochloric acid if it reacts with water. Again, if it reacts with water, it will generate 3 moles of hydrochloric acid. If it reacts with water, it will not generate any acid, rather it will generate another base. It will generate another base. So ferric chloride is the salt where it is not a question of oxide, it is a question of compound. Here, which one will be acidic or basic, we need to determine by reacting them with certain with water. Okay, then we will find the appropriate answer. Since ferric chloride, after reacting with water, will generate 3 moles of hydrochloric acid at least, that's why we can easily say that this one will be responsible for more acidic solution. So that's all from our side. As you can see, all of the questions, majority of the questions about p-block were about oxides. So I do request you to go through the oxides technique, and from our matrix you will find plenty of examples as well. You should go through all of this and practice a lot. I think that will help you to solve all the questions that come in the admission test. Best of luck.